Hey there, Andy here. So today I want to talk about a topic that a lot of people get really confused with, and I found really confusing starting off myself, and that's the topic of isomers. So there are a lot of different types of isomers, and we're going to talk about the different types and how you should think of them as you try to map it out in your head. So the first type of isomer we should cover are structural isomers. These are also known as conformational isomers. And so, what does this mean? Structural isomers or conformational isomers have the same molecular formula but have a different connectivity. So, same molecular formula, different connectivity. So, what would be an example of that? Well, we could take N-pentane. It has 1, 2, 3, 4, 5 carbons. And how many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogens versus something like isopentane. Oh, wrong shade of blue. Isopentane, which has 1, 2, 3, 4, 5, also 5 carbons and 12 hydrogens. So they have the same, number of carbons and hydrogens, but they're just connected differently. You can see there's a methyl substituent on the isopentane, and the N-pentane is just a straight chain. So structural isomers basically just have a different connectivity. That is kind of the first main type of isomer you need to know. The second main type are con. Let's use a different color. Uh, Conformational isomers. Now, be careful. Don't confuse this with the structural isomers. So, conformational isomers have the same formula and connectivity. So the same bonds and the same formula. And the way you should remember conformational isomers is with Newman projections, which you should be familiar with. So, but let me briefly go over Newman projections. Newman projections are, remember, when we have kind of this sawhorse molecule that's in 3 dimensions. Something like this, really simple. So this a Newman projection would be kind of a view, if this were an eye, a view down this line of carbons. And so you would get something that's an eye. You would get a Newman projection. Where this is the center carbon, so you'd get this H is this H right here. This methyl is right, or this CH3 is right there, and this hydrogen is there. And then you look down, and you will see a CH3, which is CH3 over here, and then the two hydrogens. And so I'm not really showing you the Newman projections, so you memorize them. You should be familiar with them, but I want you to associate conformational isomers with Newman projections because conformational isomers are specific to isomers rotating around single bonds. Around single bonds. And so with a simple molecule like this, there will always be constant rotation around that single bond because there's free rotation around single bonds. And so conformational isomers have to do with rotating around a single bond. Now it's really important that you don't confuse conformational isomers with configurational isomers. Configurational isomers have the same connectivity, let's write this down, as before, same, made of the same elements and same connectivity, but differ in spatial arrangement. Now, you may ask, how is that different from conformational? See, formational versus configurational. You need to keep that difference. But how is it different from conformational isomers? Well, as we said, conformational isomers rotate around a single bond. In this Newman projection, this bond is going to rotate right here, changing the order of this projection. In configurational isomers, it's hard to rotate. So we can have kind of the same bond, same basic setup, but now when you have, larger molecules that take up a lot of space, right? Just writing an example of something of a big molecule. Now it's really difficult. Let's draw that in a different color. It's really difficult to rotate around that bond. And so it usually won't. Usually no rotation. And I say usually because if you do things like increase the temperature, which causes all the molecules to move faster, then maybe it could rotate. But the whole idea of a configurational isomer is that it's a specific three-dimensional arrangement. And so this gets into some ideas about chirality. Chirality is a very important topic that is discussed in another video, but it basically means that something has a specific 3D arrangement. So I don't want to talk about it right here because we're talking about isomers, but definitely watch the chirality video.